Hello everyone. Welcome to today's lecture on how to build a model using ANN in deep learning. My name is Dr. Sachin Kumar, Associate Professor, MERI College, and I am excited to guide you through the important and fascinating topic. As we know that artificial intelligence is a substitute of deep learning, is a subset of machine learning in artificial intelligence, that is AI, that has network capable of learning unsupervised data that is unstructured or unlabeled. It is also known as deep neural network or deep learning network. Here are some key aspects of deep learning. Neural network, at its core, deep learning uses artificial neural networks, which are algorithms inspired by the structure and function of the brain, layers and depth. The deep learning refers to the number of layers through which the data is transformed. Learning from data, like all machine learning methods, deep learning algorithms learn from data. Unsupervised and supervised learning. Deep learning can be used for both supervised learning, where the model learns from labeled data, and unsupervised learning, where the model learns from unlabeled data to find pattern. Applications of deep learning has been successfully applied to a variety of tasks, including image and speech recognition, natural language processing, medical diagnosis, and more. Frameworks and library. There are several popular frameworks and libraries for deep learning, including TensorFlow, Keras, and PyTorch. Overview of machine learning. Machine learning is a branch of artificial intelligence, that is AI, that focuses on building systems that can learn from and make decisions based on data. ML, that is machine learning, enable computers to identify patterns and solve problems with minimal human intervention. Type of machine learning, supervised learning. The algorithm learns from labeled training data, trying to predict outcome for new unseen data based on that training. Common tasks including classification, categorizing data, and regression, predicting numerical values. Then unsupervised learning, the algorithm analyzes and clustered unlabeled based data based on similarities or differences without prior training. Tasks include clustering, anomalies detection, and association mining. Reinforcement learning, the algorithm learns to make specific decisions by trying to maximize a reward through trial and error in a given environment. Machine learning algorithm. There are so many types of machine learning algorithm. That is linear regression for predicting a dependent variable based on value of independent variables. Logistic regression for predicting binary outcomes, yes, no, true, false type of or success, failure. Decision trees and random forest for classification and regression tasks with tree-like models. Supervised machines, SVMs, for classification and regression by finding the best decision-making boundary. Neural networks for capturing complex patterns through layers of interconnected nodes, leading to machine learning for more complex tasks. Key steps in machine learning project. First is data collection, gathering that raw data that the algorithm will learn from. Data preprocessing, cleaning and formatting data to improve quality and usability. Feature extraction, selecting and transforming variables that are most relevant to the task. Model selection, choosing the appropriate machine learning algorithm based on the problem type and the characteristics. Training, feeding the data to the model and allowing the algorithm to learn from it. Evaluation, assessing the model's performance with metrics like accuracy, precision, recall, and F1 score for classification or mean squared error for regression. Hyperparameter tuning, adjust the model parameters to improve performance. Then deployment, integrating the model into a production environment where it can start making prediction or decisions. Monitoring and updating, continuously monitoring the model's performance and updating it with new data. Applications of machine learning. First is image and speech recognition, used in facial recognition system and voice control devices. Medical diagnosis next, assisting doctors in identifying diseases from medical images and patient data. Financial services for credit scoring, algorithm trading and fraud detection. Recommendation systems, powering recommendations on platform like Netflix, Amazon and Spotify. Natural language processing, and that is NLP. For transmission, translating language sentiment, analysis and chatbots. Artificial neural network, ANN, computing systems inspired by the biological neural network that constitute animal brains. An NN composed of a collection of connected units or nodes called artificial neuron, which loosely model the neuron in a biological brain. Key concept in ANN, neural model. The fundamental building block of an ANN is the artificial neuron or perceptron. It perceives one or more input representing dendrites and sums them to produce an output representing an axon. Activation function, the model, the frequency of the action potentials or spikes of a biological neuron, or an activation function is applied to the weighted sum of the input. Network architecture, the way neurons are specified is often referred to as the architecture of the ANN. It can be a single layer or consist of multiple layers, making it a deep neural network. Learning process, ANN learns from observational data by adjusting the weights of connections, which is typically done through a process known as backpropagation. Backpropagation, a learning algorithm that adjusts weights in the ANN by propagating weights changes backwards through the network from the output layer toward the input layer. Loss function is also there. During training, a loss function is used to measure how well the ANN performs. The goal of training is to minimize the loss function gradient descent, a method to update the moving weight by moving in the direction of the negative gradient of the loss function. Building an ANN model in Python. Building an ANN neural network in Python typically involves using a deep learning library like TensorFlow or PyTorch. These libraries provide the necessary tools and functions to construct and train neural networks efficiently. So step 1, install TensorFlow. First, make sure that you have TensorFlow installed in your Python environment. Pip install TensorFlow. Step 2, import required libraries like TensorFlow. We have to import TensorFlow, we have to import keras.models, we have to import sequential data, TensorFlow keras.layers, import dense, create a sequential model and add layers. Here we have build a simple network with one input layer, one input hidden layer and one output layer. Model equal to sequential, then dense, 10, activation equal to ReLU. ReLU is a kind of function, input save, input features, input layer, num input features in the number of features in the input layer, dense 10, activation equal to ReLU. Hidden layer equal to 10, with 10, neuron dense 1, activation sigmoid. Output layer for binary classification, step 4, compile the model with an optimizer loss function and a metric for performance. Model.compile, we have to compile it also. Optimizer code add loss equal to binary cross entropy for class, for multi-class. Classification, metric accuracy. Step 5, prepare your data. Load and pre-process. Your data, here is a generic way to represent this. X10 for your features, feature data. Y10 for your label data. Step 6, train the model. Fit the model on your data. Model.fit X10 and Y10. Epochs equal to 10. Batch size equal to 32. Step 7, evaluate the model. How evaluate the model? Evaluate the model on the test set. Loss accuracy equal to model.evaluate X test, Y test, print loss accuracy. And step 8, make prediction, use the model into the prediction. Model.predict X new, experiment with the architecture. Try different numbers of layers and neuron and different activation function to see how they affect performance regularization. To improve your model's generalization, consider adding dropout layer of L1, L2 categorization to the dense layer. Then tuning hyper parameters, experiment with different rates and batch sizes to achieve better performance. Thank you for this.